So there are three parts to this activity. The first part is just modeling. So I just wanted you to play around either drawing those base 10 blocks or go to the app and play around with the base 10 blocks. And then you'll need to do two things, whether you draw them or whether you use this app to make them. You'll need to identify the number you're using, and the key about these numbers is the representation of the decimal depends on what we call one whole. So here I chose that to be 1/10, but in the previous example I chose that to be one whole. So whenever you do that, when in a problem set, you'll have to make sure you have a key that says, okay, what is a whole in this situation? And if you switch wholes, you're going to say, okay, this is now a whole, so our representation changes. So you got to be clear about that when you decide to do your modeling right here. What is your whole going to be? And I make a note of that. Be sure to identify what is a whole. So you could mix it up if you want and have a different piece be the whole for multiple ones of these, or you could just use the same key for all of them. That's up to you on how you want to do that. And you could either draw it out. If you draw it, try to be relatively neat in that it should kind of sort of look like, I go back to my picture here, I'm not the best doodler these days. It should look relatively like 10 of these little guys make a long one and 10 of the long ones make a flat one. Okay, so do your best to make that as much to scale as you can. If I were drawing this on paper, I'd probably whip out a ruler, but I don't have an easy ruler on my virtual paper here. That's a little bit of a problem for me. So that's part one. That's pretty straightforward. I have no doubt you guys can do that part on your own. Next part, calculator part. And then we're going to jump into a spreadsheet part. And I'll show you why we're going to do the spreadsheet. So on a calculator, just enter 1/2, what's the decimal? Enter 1/3, what's the decimal? Enter 1/4, what's the decimal? Problem, and I have a note here about this, use an equal sign if it ended, and an approximate, the wavy equals means it's approximately equal to, because we can't do forever. We do have some notation that kind of gets around that, but it's still weird. So if I go back to some of these examples, like this one right here, the way on paper we deal with this forever problem right there is we just say, hey, 1/3 is this, and the bar indicates the 3 repeats. Right? So the bar indicates the repeating pattern. So I can kind of put an equal sign there. Otherwise, I could do something like 1/3 is approximately 0.3333, however many threes my calculator gave me. You got to be careful with the use of the bar to make sure it goes in the right spot. So for 3/11ths, I could say 3/11ths is approximately 0.2727 if I went with 4 places. Or I can kind of sort of get away with it's equal to the 0.27 27/100ths, but the 2 7s repeat. Another example we looked at was 1/6, and here only the 6 repeated because that 4 came up again, and we're going to keep getting that 4 only. So with this one, I could say 1/6 is equal to 0.16 and make it clear the bar is only over the 6, not the 1. Because note, 0.16 with the bar over the whole thing is 0.16161616, and that is not what 1/6 does. So the placement of the bar is super important. It's got to go over the right set of digits. And there can be these stalls before it goes on. And later, next class, I will show you how to interpret a number. Like suppose somebody wrote down this decimal right here. And only the 3 4 repeated, right? So that would be 0.1234343434. And so I wonder, what fraction is that equal to? We're going to figure that out eventually. Maybe we'll get to it today. So this part's pretty straightforward too. I'm confident you guys can pull that off. So I want to take a look at the spreadsheet now. And the reason I want to do that is the spreadsheet's going to help us look for patterns. Because at the moment, right, I have a bunch of pages of notes where I saw, okay, I did a fourth, it didn't repeat. I did a third, it did repeat. I did an 11th, it repeated, or 3/11ths. I did a sixth, it repeated. I skipped things, like I skipped a fifth and a seventh, and I did a seventh, and eighth. Right, so sometimes these repeat and sometimes they don't. So what we'll do is put this together in a spreadsheet. So I just want to demo how to build a spreadsheet to do this kind of thing. And there's a couple ways to make that happen. So what I want is I want a row of different numerators, 1, 2, 3, and then I want a column that shows the denominators. So for example, this cell right here is 1 divided by 2, and this cell right here is 2 divided by 2, and this cell right here is 3 divided by 2. So we're just going to play around with how to make this happen on a spreadsheet. And you could use Google Sheets, you could use Excel, you could use numbers on a Mac. Any spreadsheet will work for this. So let me get a new sheet up. I prefer Google Sheets. I usually get there by going to my Google Drive first and then picking a folder to put it in. Here and here. This is an activity. And I highly recommend giving your sheet a title right away. Sometimes I forget to do that, and I have a whole bunch of untitled spreadsheet, and I wonder what the heck's in that? Do I need that? So I'm just going to call this activity. This is 6.1. Fractions to decimals. And then, so let's see, down here are going to be my denominators, and over here are my numerators. So let's see, so maybe I'll go 1, 2, 3 there. And these guys are my numerators. And then over here, I don't want 1 as a denominator. That's kind of boring. The first exciting denominator is 2, so I'm going to go 2, 3, 4. So these guys here are my denominators. You can color code them a little bit. Denominators can be light blue. My numerators, that far. They can be light orange. That's cute. And then there's a couple of ways to make this happen. Like over here, I want this to be equal to this one here divided by that 2 there. Now, the problem is if I hit enter, no big deal, it looks and says, oh yeah, I can do 1 divided by 2. If you wanted to use the autofill button, that's going to work kind of weird. So what happened with the autofill button here is, like right now, it says, okay, the numerator is right above me. And in the next cell here, the numerator is right above. That's cool. But it switched the denominator from column A to column B. And over here, it picked the right numerator, but it switched the denominator from column A to column C. So I need a way to tell it, please don't mess with my denominators. So I'm going to teach you a spreadsheet trick if you're not familiar with it. So when I fill this formula to the right, I always want it to look above to get that number. But I don't want it to mess, I always want it to look in column A to get that 2 there. So to fix that, what I do is in front of the A, I put a $, which says when I copy this over, don't mess with me. So I'll do this twice just to double check. So I'm going to try to fill that over again. And so what I should get is 1 over 2, 2 over 2, and then 3 over 2. And that looks right. So I'm just going to repeat that down here. So if I type my formula, it says grab this numerator up here and then divide by this denominator over here. When I fill it to the right, the numerators will go okay, but the denominators will shift to the right too, and that'll screw things up. So first I'll do the bad way. I try to fill that over. This right here should have been 3/3, which is 1. That's clearly not 1. What went wrong? Well, it grabbed the right numerator, but it didn't do the denominator right. So when a spreadsheet makes a formula like this, what's happening is, I double click there, although it wrote take B2 and divide by A4, what it's really thinking is take whatever number is 2 cells above and divide by whatever number is 1 to the left, right? 2 cells above divided by 1 to the left. Watch what happens when I fill that over. And if I double click here, what did it do? It took the cell 2 cells up and divided by the cell 1 to the left, okay? That's called relative cell referencing. And most of the time it's a blessing, but in this case it is not. So to fix that, I have to realize that the denominator here always is in column A, so I put a $ in front of it saying, hey, don't mess with column A, please. And so then I can fill that over. And it should work good. So even if I kept going with like 4 is the numerator and 5 is the numerator, this formula should still work okay. So if I fill them both over, this should be 4 divided by 2, which is 2. This one right here should be 5 divided by 2, which is 2.5. So it's working okay. So one more time, for this 4 right here equals, I want this numerator divided by that denominator. And then I have to realize when I try to fill this to the right, it's going to want to change the A to a B or a C or a D. So I put a $ in front of it. And then I can fill it right. Okay. Now, with respect to what I'm doing here, there is one big hole in the way I'm doing this. Did anyone notice the problem that might occur? Yeah, and the only way to notice it is to really mess around and play with this. So I'm going to leave it at that for the moment. So what you're going to try and do is create a spreadsheet, and I can give more tips on the spreadsheet later. The point of the spreadsheet is to try and find a pattern. So I'll come back to the spreadsheet in a second. So part 1, you're just going to either draw some base 10 blocks to illustrate some fractions. Make sure you tell me what a whole is for each of them or all of them. Second part, you're just going to plug into a calculator what is 1/2, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10. Based on just those examples, can you guess at a hypothesis as to when a fraction will terminate as a decimal? By looking at which one of these terminated and which one didn't. Can you come up with a rule and say, okay, I think if the denominator looks like this, it'll always terminate. Okay? So you're going to come up with some kind of guess. Don't worry about being right. Just make a guess, right? Whenever I make a first guess at some pattern I've observed, I'm usually wrong the first time. And then I revise my guess. The point of the spreadsheet is to give us a ton more examples. And I want you to build a spreadsheet with denominators up to 32. I picked 32 for a special reason that hopefully we'll figure out the next time we meet. So that means in my spreadsheet, over here, that here my denominator so far I only have up to 9. I want to continue that pattern to 32. I don't look too far there. The numerators, I don't really care how far the numerators go out. They could stop, I don't know, 5, 6. Maybe I'll stop at the numerators at 10. So the numerators don't need to go out to 32, but I want to see some different numerators up here. If you just look at 1 divided, you don't get a full picture of what's going on. But at the very least, you want to go up to 5, say. But you don't need to go up to a numerator of 32. Denominators definitely have to go up to 32. And what we want to do is then look at this and say, okay, when, for what denominators did things repeat? For what denominators did things terminate? Is there a pattern to the kinds of numbers that lead to repeating decimals and the kinds of denominators that lead to terminating decimals? That's the goal we're trying to figure out here. Okay, questions? And this is something like you just got to kind of play with and think about it and test your thoughts. Is that really true, what I thought? Like earlier, for example. So here's we looked at 1/3, that didn't terminate. We looked at 1/11, that didn't terminate. We looked at 1/7, 3/7, that didn't terminate. So maybe that means if the denominator is odd, it will repeat. And if the denominator is even, it'll terminate. Right? So that could be a hypothesis. But then I say, oh, but wait, 1/6, that's an even, and it repeated too. Okay, so it's not just even or odd. Right? So there's an example of me making a hypothesis, and then I tested my hypothesis, and it was like, ah, shit, it wasn't right. Okay, back to the drawing board. Okie dokie, that is all I have at the moment. I just need you guys to play. So would you guys like to play together for a little bit in breakout rooms to talk about this? Or we could just stop here.